All right, study guide number 3. Problem number 1 on the study guide. Let's see, what is the solution to each proportion? On the first two problems, you're given a proportion. So if 3 over A is equal to 15 over 20, in a proportion, cross products are equal to each other. So you're going to crisscross multiply. So 15 times A is 15A is going to be equal to 3 times 20, which is 60. And you can divide both sides by 15. A is going to be equal to 4. Same thing on number 2, 7 over 9. It's going to equal M over 36. Sometimes you can do these. 9 goes into 36 4 times. So 7 times 4 would be 28. Or you could just crisscross multiply. 9M is going to equal 7 times 36, 252. Divide each side by 9. M equals 28. Both ways will work. Number 3 says, given the proportion, A over B equals 9 over 17, what ratio completes the equivalent proportion A over 9 equals, all right, so look what happened. A over B equals 9 over 17. All right? And they're saying complete this proportion. Now you got A over 9. So didn't they switch these two?
Yeah.
They took the 9, put it where the B was. So if they do that, you got to take the B, put it where the 9 was. So the B goes here. 17 still stays on the bottom. All right, so those are two equivalent proportions. In number 4, you are asked, are the polygons similar? If they are, write a similarity statement and give the scale factor. So you've got these two parallelograms, or they appear to be parallelograms. All right? The shape on the left has sides that are correct. Opposite sides are equal. So you've got an 18 and an 18 and a 9 and a 9. And this is 120 degrees. And then you're asked if it's similar to this shape. All right, and in this shape, opposite sides are congruent again. This is 504, 5.04, 1.8, and 1.8. And this angle is 120. By appearance, they look as though they're similar. All right? Because if opposite sides are congruent, then opposite angles are congruent. All right? So, in these two shapes, they appear to be similar. Okay? Because they're going to have the same angle measures. But if you look at, in order for them to be similar, the corresponding sides have to be proportional, right? So look, this 18 over 9 would have to equal, or better yet, really, the way we talked about it all week was the long side of this shape over the long side of this shape. So the 18 over the 5.04 would have to equal the short side, which is 9, over the short side, which is 1.8. Okay? Now, the easiest way, well, there's two ways to check this. You can divide them both, all right? Or you can crisscross multiply. So 18 times 1.8 is 32.4. Is that equal to 5.04 times 9. Well, you know that 5 times 9 is 45, right? So this product is going to be more than 45. It's going to be 45 plus. So are these proportional? No, they're not proportional. So are the polygons similar? It's just a no. Okay? Number 5. Number 5 says the polygons are similar but not necessarily drawn to scale. Find the value of x. All right, so your proportion to find the value of x for number 5 would be 12 over 35 is equal to 6 over x. And then you can crisscross multiply. So 12x is going to equal 210. Divide both sides by 12. And x is equal to 17.5. Number 6. Here's your given information. The question is, are the two triangles similar? How do you know? All right, in these two triangles, you can see that H is congruent to K. And you know that vertical angles are congruent. So these angles here formed by point M are going to be congruent as well. And there was an angle similarity theorem that you had this week, that if two angles in one triangle are congruent to two angles in another triangle, then the triangles are congruent. So, are the two triangles similar? Yes. How do you know? You're going to say angle, similarity. That's the rule that you can apply to prove that those two triangles are similar. Number 7, state whether the triangles are similar. If so, write a similarity statement and the postulate or theorem you used. So the two triangles that you're looking at are O, K, J, and then the triangle, the big triangle around the outside, which is O, N, M. Are those two triangles similar to each other? So be careful here. Both triangles share this angle, don't they? So, you know one angle. Now, look what else you know. You know two sides in the first triangle. And in this big triangle, you know that this side is 4, and this side is 24. So you know a side, an angle, and a side. So the next step is to determine if the corresponding sides are proportional. So if you do the shorts or the bottom side of this triangle, which is 3, over the bottom side of the big triangle, which is 4. And you see if it's equal to the top side of the small triangle, which is 18, over the top side of the big triangle, which is 24. Does 3/4 equal 18 over 24? You can crisscross multiply if you want, but 3 times 6 is 18, and 4 times 6 is 24. Okay? So these are proportional. So, state whether the triangles are similar. Yes, they're similar. If so, write a similarity statement and the postulate or theorem. So the similarity statement, 3 different options for this similarity statement. So if we go OKJ on the first triangle, triangle OK to J is similar to triangle ONM. Very good. All right, we went the same order around the triangle. And the postulate or theorem you used. We used side, angle, side, similarity. Good? Number 8. (16), 8, 32. Here's the clue in this question. They tell you that this piece is parallel to this piece. All right, which theorem or postulate proves the two triangles are similar? Talking about this top triangle and the triangle around the outside. All right, so look, since these two horizontal lines are parallel, it makes this line down the left, it makes the other two sides of the triangle transversals. These angles are corresponding. So they're congruent to each other. Both triangles, the little triangle up top and the big triangle around the outside, have this angle. So don't you have 2 angles in one triangle congruent to 2 angles in another triangle? They both have they each have 2 congruent angles in them. Exactly. So which theorem or postulate proves they're similar? That's going to be angle, angle, similarity. Angle, angle, similarity. Number 9, same directions. The bow tie problem. (27) here on the left. This angle, this top left angle is congruent to this bottom right angle. Sure. 19 over 3. And 19. Or which theorem or postulate proves the 2 triangles are similar? You're only told that this one angle is congruent to this one angle. But again, what's going on here in the middle? This vertex in the middle has vertical angles around it, so these are congruent to each other. So are the 2 triangles congruent? Yeah. And you can say angle, 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 similarity. And in this case, they don't ask you, are the triangles similar, and if so, why? They just ask you which theorem or postulate proves the 2 triangles are similar. So you're told they're similar. All right, number 10 is an extended ratio problem that says a salsa recipe uses green pepper, onion, and tomato in the extended ratio 1 to 3 to 9. If the ratio is 1 to 3 to 9, and you're going to make 156 cups, you set up a formula, 1x plus 3x plus 9x, and you make it equal to the number of cups that you're trying to make, which is 156. Combine like terms. So 1 plus 3 is 4 plus 9 is 13x equals 156. Divide each side by 13. And x is equal to, right. But now, x is equal to 12. And answer A might be 12. But that's not the question that they asked. They asked how many cups of onion. So if your multiplier is 12, but your onion is right here, 3 times 12 is equal to 36. So you need 36 cups of onions. In number 11, to measure the angles of a triangle are in the extended ratio 2 to 3 to 10. What is the measure of the smallest angle? All right, so if the three angles in a triangle are in a ratio of 2 to 3 to 10, then 2x plus 3x plus 10x, what does it have to equal? Angles of a triangle. 180, good. So you combine like terms again, and 2 plus 3 is 5 plus 10 is 15x is equal to 180. You divide both sides by 15, and x is equal to 12. Exactly, that's not it. But think about if you were a test writer and you were trying to get someone to answer incorrectly. I would make answer A 12 for the people that didn't read the entire question. So they're asking for what is the measure of the smallest angle. So that's going to be your multiplier times 2. So 2 times 12 is 24 degrees. Number 12. What is the value of x? X is right here. And you've got a 6, a 24, and a 28. Given that PQ is parallel to BC. All right, so you're told that PQ is parallel to BC. So yesterday, we talked about a segment that intersects the sides of a triangle. If it's parallel to the third side of the triangle, then it splits the other two sides proportionally. So you can set up a proportion here to solve for x. You can say that 6 over 24 is equal to x over 28. Crisscross multiply. So 24x equals 6 times 28 is 168. Divide each side by 24. X equals 7. No, that says given that PQ is parallel to BC. That was the clue in the problem. If these two weren't parallel, you don't know that these four segments are proportional. All right, so when they told you that PQ is parallel to BC, then that's your clue to set up a ratio to solve for x. All right, number 13. Plots of land between two roads are laid out according to the boundaries shown. The boundaries between the two roads are parallel. So the boundaries are all parallel. So you've got this road here and another road here and all these boundaries that are parallel to each other. All right, and we covered this theorem yesterday. So you're given that this is 40 yards and this is 48 yards. You're told that plot 3 has a property line that's 75 yards long. And the question is, what is the length of plot 3 along Cheshire Road? So that's this piece right here. So make it a variable. All right? Set up a proportion. You could do 40 over 48 equals x over 75. Or you could do 40 over x equals 48 over 75. Either one. I'm going to do 40 over 48 equals x over 75. Crisscross multiply. So 48x equals 40 times 75, 3,000. Divide both sides by 48. And x equals 62.5. Number 14. You were given this rule yesterday regarding an angle bisector. So in this case, you have a segment that bisects this angle of a triangle. You're told that the sides created by the angle bisector are 5.4 and 5.6. That this side is 11.5 and this is x. What is the value of x to the nearest tenth? All right, the rule yesterday said that an angle bisector in a triangle creates two segments that are proportional to the two other sides of the triangle. So you can take your 5.4, which is this side created, or this segment created, over its adjacent side, which is x, and set it equal to 5.6 over its adjacent side, which is 11.5. Okay, so that's your setup. So 5.6x is going to equal 5.4 times 11.5, which is 62.1. And then you can divide both sides by 5.6. X is equal to 11.1. And number 15. An angle bisector of a triangle. All right, so let's get a triangle. and an angle bisector. I don't care. Angle bisector of a triangle divides the opposite side of the triangle into segments 7 and 5. So 7 and 5. A second side of the triangle is 3.7. Alright, so they're saying that either this top side or this bottom side is equal to 3.7, but they're not telling you which one. Find the longest and shortest possible lengths of the third side of the triangle. So what you have to do is find out what the third side of the triangle would be when this 3.7 is on the bottom, and then when the 3.7 is on the top. Okay? So you're going to set up two ratios. You're going to set two proportions, and you're just going to solve them both. You're going to set up one proportion when the 3.7 is here with the 5. So you can do 5 over 3.7 equals 7 over a variable. Crisscross multiply. So 5x equals 3.7 times 7, 25.9. And then divide each side by 5. 5.1 or 5.2, right? So x in this case equals 5.2. So there's a possible value when the 3.7 is adjacent to the 5. So then you got to do the same problem when the 3.7 is adjacent to the 7. All right, so you're not going to use that anymore. You're going to move it to here. And you're just going to repeat the same process. So now take 7. Let's go 7 over 3.7 equals 5 over a variable. And just repeat the process. So 7y is going to equal 3.7 times 5, which is 18.5. Divide each side by 7. $2.6. Alright, so the question was find the longest and shortest possible lengths of the third side of the triangle. Round your answer to the nearest tenth of a centimeter. So here's the shortest, and here's the longest, so that the triangle still meets the criteria of an angle bisector splitting the sides proportionally to the other two sides of the triangle. That completes study guide for quiz 3.